Unite beyond boundaries. Innovate together. Joe's PANKRATIon 2024. No border.
Please go ahead.
Hi, good morning, good afternoon, good evening, wherever in the world you are. Thank you very much for taking time off your day to come and listen to my session about serverless website analytics with Lambda Edge. I'm super excited to be here today to talk to you about this topic. I'm Jimmy. I'm a AWS ambassador and AWS community builder and a user group leader based out of Sweden. I'm also the founder of serverlesshandbook.com, a space where you can find all of my serverless adventures. I work as head of AWS at Sigma Technology Cloud. We are an advanced service partner based out of Sweden. So a quick look at today's agenda. So we're going to talk about the problem I was facing. And next we're going to follow up on the solution, how I started working out the solution to this problem. I did run into some problems, so we're going to look at some gotchas that I got from this adventure. And we're going to look at the refined solution that is running in production today. And we're going to end everything with a short summary of what we've been talking about. So let's start about the problem. I run a personal blog where I write blog posts on a regular basis. And then I needed a way to understand my readers. I wanted to understand from where in the world they were coming, and what blog posts they were accessing and reading the most. I had been using Google Analytics for this for a very, very long time. It's been my tracker for many years. However, Google decided to deprecate the universal analytics. That meant I needed to migrate my analytics solution to the newer version of Google Analytics. And when that happened, I could also look into other solutions. Instead of just migrating, I could look into a different solution. And to be honest with you, Google Analytics was way too advanced for what I needed. And it can do so many things, and I only used a small portion of it. So I looked at some open source alternative that plausible and Matomo. They were really good, but they require me to host my own EC2 instances and host my own version. And that was not something I wanted to do. I also looked at Fathom Analytics, a SaaS offering around analytics, but it's not free, and therefore I didn't decide to go with that. So the frustration grew. I just wanted an easy way to understand my readers. I mean, how hard can it actually be? So I started to think, can I build this my own? Can I build this tracker that I need on my own and use my backend solution? To understand a bit about my blog, it's running out of S3 with a CloudFront distribution. It's a 100% static website, so it's HTML all the way. So I didn't want to have a lot of JavaScripts injected into every one of the blogs that called analytics server. So my thought was, can I do it on the backend? Could I use my CloudFront distribution for this? So I started to sketch. I started to draw up a solution. I started to draw up an architecture on how I would be able to solve this in a serverless way. I had three thoughts. I didn't want to have a client-side tracking, as I said. I don't want to inject the JavaScripts that the readers need to call some of my backend. I needed to understand what post or what blog post or what page the users were accessing. I wanted to know the time of day, and I wanted to know from where in the world they were accessing my page. So the thought was, can I integrate this somehow into my CloudFront distribution to get all of this data? I also want to make sure that I had a decoupled and an event-driven solution. Me, I'm a serverless guy, so I want to build things serverless and event-driven. Having viewer requests on my page logged as events, that's a perfect event-driven solution. And I also wanted to decouple the ingestion, the storage, and the analytics parts. By doing the decoupling, I could easily swap out some of the parts in a later stage. Before we move into the ingestion part, we need to understand a bit about CloudFront and CloudFront integration points. There are four main integration points. The viewer request that runs on every time the viewer accesses CloudFront. We have the origin request that runs when CloudFront accesses your origin. The origin response is run before CloudFront puts things in the cache, and the viewer response is run before result is returned to the viewer. I was already today running a CloudFront function on the viewer request. That function does some path manipulations to better serve my blogs to my readers. There is two ways to integrate with CloudFront. You can either integrate using Lambda Edge, which is a Lambda function. It can run on all of the 4 integration points. It has network access and can access AWS services, which is what I need in this solution. It can run for 5 to 30 seconds. CloudFront functions can only run on viewer request and viewer response, and it does not have any network access, meaning that I can't access any other AWS services. And it has a sub-millisecond duration time. So with that understanding, I needed to run this on a Lambda Edge. I can't run my solution on a Lambda or on a CloudFront function because I need to access other AWS services. So this is the first architecture on the ingestion part. CloudFront would hook into the origin request and we invoke a Lambda Edge function. That Lambda function would collect all the information that I needed and post that onto EventBridge as an event with all the information needed. The data store could then just hook into EventBridge, create a rule, and subscribe to the events coming from a web page. A Kinesis data Firehouse could easily buffer and store the data into an Amazon S3 bucket that I can use for later analytics. In the analytics part, I can have a glue crawler that crawls the S3 bucket and calls all the data. With Athena, I can do queries towards it. I can do SQL queries and SQL manipulations. And in the end, I can visualize everything using a managed service for Grafana. So I went ahead, I started building this solution. And after a while, I actually started running into some issues and some problems. The 3 main problems that I had was that the solution suddenly failed to deploy. I got a very cryptic error message. I was missing some data. I was missing some time information. I was missing some viewer information. But I was also missing a lot of events. I could see basically the first event, but then subsequent event was lost. And my page felt a bit sluggish. I knew the performance of my page from before, and now it started to feel a bit slower. So the main gotcha from this one is that Lambda Edge and CloudFront functions can't combine. Meaning, since I was running a CloudFront function already on the viewer request, I could not run a Lambda Edge on the viewer response. That is not possible. I can't combine those two. The error message coming from AWS, however, was very, very cryptic. It did not say anything around that. It just said deployment failed. It took me almost a good day to figure out the problem and fix it. Lambda Edge calling EventBridge is a synchronous invocation, and that introduced a high latency, or around 25 milliseconds latency, which was enough to make my page feel a bit sluggish. Also, Glue has a requirement on the files that Glue calls in S3. Each of the data objects in the file need to be separated, clearly separated with a new line. When running through Firehose, the default mode of Firehose is not to add any form of new lines. Firehose just writes each data object after another. Instead, I need to add a transformer onto my Firehose. And that transformer is a built-in transformer that adds that new line after each data object. Now, before that transformer actually existed, it's a newer thing, you actually had to do that transformation with a Lambda function. And since I now had moved things to viewer response, I needed to add certain headers into my cache policy. So I got the time to access country and what type of device the user was accessing from. So I started to build out a new solution, a new refined solution that were going to fix my problems. So the things I needed to solve was the high latency. The page felt sluggish. I needed to have a better view of time and date. I got a one single string with time and access date. I didn't really care that much about the time. I just wanted the date, but I wanted to keep time for later reference. So I needed to split things up. I also needed a better way to handle viewer type, because I got from CloudFront, I got if it's a mobile device, true false, if a tablet, true false, or if it's a desktop, true false. but I can't really do good SQL queries on that. I just wanted one field, viewer type, and a string. But that could be easy then to do SQL queries on. So I started modifying the ingestion part. So I kept the Lambda function and running it on the origin response. But instead of Lambda invoking event bridge directly, it actually asynchronously invokes step functions. That way the Lambda function returns immediately, but the step function takes over and can process the information. The sluggishness went away, and step function could do processing and put the event back onto event bridge. The step function state machine looks something like this. I get the data and parse the information coming from CloudFront. Here I could split up time and date in a good way. I could also do a check to see if it's a mobile, tablet, or desktop viewer, or something I didn't recognize, and create one single field called viewer type. I could then create the data object and pass that onto an event bridge as an event using the built-in put events system. Not a single Lambda function, everything is just built with API calls and SDK calls from step functions. So the new refined solution ended up looking like this. I have my CloudFront function, CloudFront Lambda Edge running asynchronously invoking the step function. The step function puts the process events and puts it onto event bridge. Now Kinesis Data Firehose picks up the event, adds the new line after the data object, and stores it back into the S3 bucket. My glue crawler, I have it running once every night. I don't need to have more granularity than that. So I run every night, process information. And I can have Athena then do SQL queries to the data in glue. And I use managed service for Grafana to create the visualization. With all this decoupling in place, I could actually hook in new things onto my event bridge. If I want to do some different processing, I'd maybe not want to use Kinesis Firehose S3, or maybe want to store it some other way in a DynamoDB table or something else. That's very easy now to extend since it's all event-driven and decoupled. The total cost of running this solution, which could be interesting, is that the managed service for Grafana is the most expensive part. It's a fixed cost of $9 per month per user. Since I'm only one user, I pay $9 per month. S3 costs around $5, and that's mainly for API calls get and put, since I get a lot of different objects and have a lot of readers. Glue costs around $2 per month to index my information. Lambda, step function, event bridge doesn't even show up on the invoice. It's a $0. So the total cost of running the solution is around $16 per month. To summarize everything what we've been talking about in the last 15 minutes, now I know what blog post is accessed from my readers and at what time. And I can visualize everything, where in the world the users are located and what blog posts are my top blogs. I can create the dashboards using Grafana to actually show this information in a good overview way. And to show you, this is a screen from pulled out today, this morning, just before this presentation started. And it shows the information from the last 30 days. I can see that I have around 200 unique readers on a daily basis. And the last 30 days, I've been reading almost 10,000 blog posts from almost 6,000 unique readers. Unique readers are counted on a daily basis, meaning that if a reader accesses my blog post today and tomorrow, it will be counted as 2 unique readers. I don't have a monthly span on the unique readers. I can also see from where in the world on this map my users are accessing me. I get some trends and can follow up a lot more on the statistics using this. If you want to build out this solution yourself or try it out or adapt it to your use case, it's available on Serverless Handbook. So serverlesshandbook.com/serverless web statistics would bring you to my GitHub repository where you can download and fork this solution and build it out on your own and run it on yourself. So that concludes my presentation for today. Thank you very much for listening, and please follow me on LinkedIn and Twitter. Thank you.